Hello, and welcome to today's video. In today's video, what we're going to be discussing is how to go ahead and create an experiment. So we will be discussing how to develop a testable question and what to do once you have it. So before we go ahead and move on to the next slide, real quick, if you actually know what movie this scene is from, please go ahead and come find me. I will make sure to give you the most righteous of high fives. Anyway, let's go ahead and get started. So a controlled experiment, simply put, is designed to test a hypothesis. And the important thing to know about a controlled experiment is that you only change one variable. Now remember, if you change too many variables, the experiment isn't going to get very valid data. So only change one variable at a time. Speaking of variables, make sure you know yours. The first we're going to discuss is the independent variable. This is something you go ahead and change on purpose. The dependent variable is something that you measure based upon the change you made. So it's going to be what you're measuring based off of your change. The next one is the control group. The control group does not change and is used as a basis of comparison. So what I mean by that is, think of it like this. If you're going to go ahead and test the effect of different fertilizers on plant growth, your control would be the soil without any fertilizer. So it's the normal condition that you're using to compare everything else to. If you don't have a control, you have nothing to compare to. Finally, we have our constant. A constant is any value or condition that does not change. So think back to the example we just talked about with the growth of plants. So constants would be like the temperature, how many seeds you planted, the amount of water you give it each day, and anything of that nature. So when writing a hypothesis, this is predicting the effect of the independent variable on the dependent. These are based on your observation, so observation is always the first step before you come up with a hypothesis. It has to be testable. A hypothesis that isn't testable isn't worth anything. And it has to be written in an if-then format. So simply put, this is how a sample hypothesis would look. If blank is blank, so if the IV is changed, then the DV will whatever you expect to happen. So for example, if the temperature is increased in an area, then the number of pill bugs in that area will decrease. What we're changing is the temperature, what we're measuring is the number of pill bugs in an area, and the effect that we are expecting to see is that they will decrease. When you actually run an experiment, there are some things you need to keep in mind. There are your procedures. Your procedures are the directions for an experiment, and these should always be step by step and numbered. Make sure to explain what you're doing. Somebody should be able to take your procedures and go ahead and replicate your experiment to the letter based off of what you've written. Your trials. So trials, the experiment should be done multiple times for each variable you're testing. You don't want to go ahead and only test something one time. Make sure that you have a multiple variety of trials and that you're recording your data after every single time. This will give you some nice data to go ahead and compare later on in the experiment. Your types of data. The first type is quantitative data. So quantitative, think quantity. These are numerical pieces of data, so things that can be measured. For example, length, height, volume, and temperature. Now qualitative types of data, however, are descriptive. These are qualities, so qualitative qualities. And these are anything that can be observed, such as color, texture, smell, behavior, and anything else you could go ahead and see. Sample sizing. When creating an experiment, it's very important to keep the sample size in mind, and the sample size is the number of subjects in your experiment. A bigger sample size gives you better averages and more representative results, so it's more honest and more real. So simply put, the bigger your sample size, the closer your hypothesis becomes to being true, or false depending on what your results are. So this is the same thing with trials. This is why we do multiple trials, to make sure that the data you're getting is accurate. If you went ahead and flipped a coin one time and you got heads, that doesn't mean that every time you flip a coin, it's going to be heads. Making an inference. An inference is something we go ahead and create all the time. An inference is drawing a conclusion based on evidence or observations. So you go ahead and look at something, and then you create a conclusion or a statement based off of what you saw. So for example, in the hallway I see a student wearing a shirt with Batman on it. My inference is this student likes Batman. Yeah. Sources of error. Now, this can go ahead and attribute to data that isn't quite accurate. There can be no control, nothing to compare to, not enough trials, the sample size is too small, the sample does not represent the general population, there can be human error, so normally with measurement, or incorrect, inappropriate tools or equipment, so you're using the wrong tool for the job, or incorrect, inappropriate variables, so you're testing something that you didn't originally say you would test in the hypothesis. These are all valid sources of error, or reasons why your data might not look correct. Some reliable references include peer-reviewed journals. These often have primary sources that have gone through and done the experiment already. Textbooks give you a basic background for your information. Newspapers find current events, and you can always go ahead and search the web. Just remember, .gov and .edu sites are normally very reliable. Finally, just some steps in the experimental design. The first step is to observe. The second, come up with questions. Third, write a hypothesis to test these questions. Then write your procedures, carry out your experiment, gather your data, analyze your data, come up with a conclusion, and then share your findings. And that is going to go ahead and close up shop today for the experimental design. Thank you very much for your time, and if you have any questions, make sure to go ahead and contact your instructor, and they will point you in the right direction. Thank you very much for your time again. Until the next time, you take care, and I'll see you later.